Hello everyone and welcome to Extreme DX. I'm your host Bruce. This week we're going to start on another project. We're going to work on a transistor curve tracer. A lot of you with radios that are getting 30, 40, 50, 60 years old may not realize it, but some of the transistors in your radio are beginning to deteriorate and have less gain. Less gain, less RF gain means not as good reception. It's something that you want to fix. This is not the curve tracer board that I really wanted. I wanted one that was available on Tindy, but I'm beginning to think it was a bit of a scam because I've waited several weeks and I haven't gotten my board, and all I've gotten is an excuse that it has something to do with tariffs. So I wouldn't recommend going on Tindy to buy anything. Now this board can be used standalone the way it is. You just have to supply it with plus minus 15 volt power and plug in the transistor, make a couple of jumpers, and then look at the scope on the XY output. But this board's not very convenient, just sitting here the way it is. I find these boards are a lot more useful if you go ahead and put them in a box so that it's self-contained. You plug it in, turn it on, hook it up to a scope, plug in your transistor, and away you go. So we're going to concentrate on laying out a little box and building it. First step is kind of doing a rough layout of the way things are going to fit. I've got a modular power supply. It's going to feed a plus minus 15 volt supply that I got off of Amazon. I've positioned the board so that I can get to things like the connections for the power without having to go over the board too much. The first step is hooking up the little modular supply to AC. I've got a switch on it and I can now proceed on to the next step. I do want to mention that you want to totally encapsulate the line and neutral and any switch contacts with hot melt. You're dealing with AC, you don't want any accidents. And here is with the plus minus 15 volt board wired in. I also took time to mount the main curve tracer board. I put red LED on the positive and blue LED on the negative so that I can tell if both supplies are up. The next step is to attach some BNCs to the XY scope outputs. BNCs are a lot more common than anything else, so I chose them, and I took a piece of scrap proto board I'd salvaged from another project to use that to hold the BNCs, mainly as a mechanical connection so I could screw them to the panel. And I had to do some rather ugly drilling because the BNCs are on a 50 mil spacing and not 100 mil spacing, but it works. Next I added the PNP NPN switch and the signal power switch to the top, where I'm also going to put the test sockets. Gave it some extra length on the wire so that I can open the package up, but I'm not going to open it up once I get it running in all likelihood, but this way I can service something if it does need to be serviced. And lastly, I put in this little adapter board for the connection to the transistor. All I had on the board down here was this 4-pin arrangement of emitter, base, collector, then another emitter, which is nice because some transistors are emitter, base, collector, and some are base, collector, emitter. So I wired this little adapter to have that same feature. But one of the things that I'd want to do is match transistors for audio stages. So I made an A-B arrangement so that I could switch this switch to select between a transistor here and one up here, or this socket and this socket. So that way I can match the transistors a lot more easily. Of course, I highly recommend using one of these little testers first. It's a lot less trouble to identify a defective transistor, and it also is a good way of determining the pin out before you hook it up to the curve tracer. You don't want to hook it up to the curve tracer backwards or something like that. I don't think it'll damage anything, but it will give you a false impression that a transistor is defective. So this is a very useful little tool to have next to your curve tracer. I put two transistors with the exact same part number, 2N2222, into the tester, and one of them has a beta of 29, the other has a beta of 141. So even with the quick tester, I know that these transistors are quite different in characteristics, even though they have the same part number. And there's what the curve tracer looks like. Not very nice. I'm sure an analog scope would have something that would be a lot more recognizable. However, if you're trying to match transistors, this is the one with the beta of 141, and that's with the beta of 29. So, if you're putting this in an RF stage in a radio, you really want this. You want more gain. Even if the part number is the same, you want to go through your stock of transistors and find one that's got a decent beta, which corresponds to the gain. Well, that's about it. My little transistor curve tracer. Again, if I get the better one, I'll do a review of it, but for now, I would advise against buying things off Tindy because I just don't think they're set up with buyer guarantees. And I have someone that has cashed my check, got my money, and has not sent me product and used a lame excuse about something to do with tariffs. Maybe it is, maybe it isn't, but the fact remains I sent money, I got no product, I ain't happy, and Tindy is not a safe platform as far as I'm concerned.